Until the engine temperature reaches and exceeds 120 to 140 degrees Fahrenheit, the desired air-fuel ratio is rich. When the engine temperature reaches and exceeds 120 to 140 degrees, the desired air-fuel ratio is no longer rich for all conditions. The change in desired air-fuel ratio can be readily seen in this video by observing engine temperature and O2 volts. The ECU calculates load based on programming and input from map, TPS, and engine speed sensors. If we focus on TPS and O2 volts, we can observe the desired air-fuel ratio as not rich when TPS is below about 35 to 40%. We can observe the desired air-fuel ratio as rich when TPS nears or exceeds 40%. Engaging the deck requires additional power from the engine, and the desired air-fuel ratio remains rich for longer periods of time. There are numerous Kohler EFI engines available. These engines have different power ratings and design intentions. Because of this, ECU programming is unique to the engine specification, and the desired air-fuel ratio may switch from rich to not rich at different TPS percentages than seen here. Remember, TPS is only one of several sensor inputs used by the ECU to calculate airflow and the desired air-fuel ratio.